committee for inviting me. I will not go into much detail because I would like, as stressed, you should grill me and get much of the information out of me. But at the same time, I must apologize that I am not a climate scientist, because there is a huge difference between being a climate scientist and somebody who speaks about the climate. But being a scientist, I believe in science, so my additions or my suggestions and my thoughts are very scientific. So I thought we'll just run through and try to understand what is climate change. First thing, of course, is that climate change is not weather change. This is the biggest confusion that everybody has in their minds. For actual climate change, you must have records for a minimum of 70 years. It is only after 70 years you can say that there is a climate change. The changes that we see today, we are all putting into climate change only because we have 70 years of records which tell us that the temperature is higher than what it was 70 years ago. If not, we wouldn't have thought of climate change. So this has been an ongoing debate all the time. How do you predict it? How do you say this and all that? But it's very important to recognize this difference, climate and weather. Weather changes are what we experience every day. But some of these weather changes are a result of climate change. That is how we try to explain. So bear with me when you hear the words weather, climate, that these are not the same, they are very different. And if you don't have records for more than 70 years, you can't be talking of climate change. Now in that position, Sri Lanka is very, very good, because our weather records go back more than 150 years. One of the few countries in Asia which has weather records over 150 years. We have had a climate pattern of 30 years when it was analyzed last in somewhere around 2000 by one scientist, Tambiraja. He showed that we have a rhythm of 30 years, that is 30 years hot, 30 years cold, 30 years, within which there is a 10-year cycle. So sometimes you have the 10 and the 30 overlapping, and then you have extreme situations. So this has been there, we knew that. Right? So we had a drought in 74, we had a drought in 94, and like that we have seen heavy rains in the 40s when we first really understood what was happening, and so on and so forth. Now we have these 30 going like that, a 10 going within that, and both of these are changing and going up. So that is what climate change is all about. So having understood that technological jargon a little bit, so collective picture of warming world and other changes in the climate system is something that has happened. 2012 was warmest ever recorded year of any data across the world everywhere. It's getting warm all the time. So last year it became again one of the warmest summers, but it didn't be for the whole year. But so it doesn't, because when we draw a graph, this is the other problem we have. We draw a graph like a straight line, and we think that everything is going like a straight line. It doesn't. It just keeps going up and down all the time. So simply it was warm last year doesn't mean that it is going to be warm this year. It can be higher or it can be lower, right? So because it's just a burst of ups and downs. 50 years nighttime minimum temperature increased by 2 degrees per decade. So you can see how it is happening. So the last 50 years, the records are showing that the night temperature is increasing by 2 degrees. These are just some statistics. We'll run through it quickly, right? So this is what is happening on the graph. You will see different times and different periods. So 20,000 years ago, the temperature was somewhere around there, and then we see it going up, and this is the Holocene optimum, and then you see it's going down and up and down, and then what is interesting is that after the 21st century, this doesn't seem to go down. It is always seems to be going up, and we are predicting that it is going to go right to the top. This is where we are recognizing that there is climate change, and this change is an incremental change, not a decreasing change. Despite all of this information, we know that there are some who will say that there is no climate change. Right? So we have to be careful, because Today, if you take the United States of America, they don't believe in climate change anymore. They have all just reversed themselves to say that there is nothing called climate change, because 6% of the US environment budget was cut, and of the 6%, almost 90% was on the climate sector. So they have always had this problem, that they want to believe that they are not the people who have contributed most to the problem. But we in the developed country have always been saying that the developed countries, of which United States of America was the principal country which has contributed to the much of the problem that exists. And there were times when they tried to say, no, we are not the people, it's India. I'll come to that later. I'll leave you in a little bit of thinking, say, why India? Right. Anyway, so these are the trends that we are seeing, and whether we take it with the lowest level or the central estimate, middle or high, definitely the temperatures are going up. Surface temperatures of the ocean and on land, everything is going up. So it's very difficult for us to say that this is not happening in terms of the records that we are getting. But when sometimes they say, well, this is nothing unusual because this has been happening all the time. But put it together and you can see we are definitely on an incremental temperature system. The problem is, where is it happening? Because this is a huge world, right? So global temperature means what? Now, this picture is just trying to show you where the actual temperature increases are seen. Where these balls, these colors, you can see this is +1, right? Where it is large is the places where much of the higher temperatures are occurring. So it's not uniform across the world to say that the temperature is increasing everywhere by 1 degree centigrade or 2 degrees centigrade. It's different in different places. And this is Australia right on top there. If you are looking in around, you have even a dip here, right, which is minus here. That blue thing means that the temperature has really dropped there, right? So Africa in the eastern sector here, it's very high. Out here in the oceans, in these places, it's low. Then if you look at, there is a 10% reduction of snow cover. All of these things are what we call the results of the increase in temperature. 2 weeks annual duration of lake revise over the 20th century. So these are generally, I'm just putting these things. Very general things, I didn't want to put in technical stuff here. The mountain glaciers, there is a very interesting set of pictures of the Mount Kilimanjaro, how the ice cap has been decreasing over the years. There is another set of pictures of glacier in the Himalayas, how it has been decreasing over the years. At different times where pictures have been taken. So all of them are indicating very clearly that things are changing. The sea ice extent, so much of pictures that shows us how the ice is breaking up, and in fact we know for a reality that the ice cutters, that's the ships that used to go to the north, have reduced their strength. The need to have a very strong hull has been reduced, and they know that, and the ship makers are so very happy that they don't have to make ships with such stern cutters anymore. And some countries are very happy about the fact that the ice is melting, because if you think of Russia, for example, to go across from the St. Petersburg or from Moscow corner to the other side on the east, Vladivostok, you have to go on land, but now you can go by sea, and it makes it much easier, and it's much cheaper. You know, even today the cheapest transport is water. It's just that it takes a little too longer. Otherwise, it's still the cheapest to go around. So they are getting good transport facilities. Canada, again, very happy that they are getting a lot of transport opportunities. And then land that was under permafrost and things like that are softening up, and that's good agriculture land. Right? So while these are there, so there are a lot of problems like this. But still there are people who like it also. So our thickness has come down. So 22 centimeter during the global average sea level. Now what is happening as that? Again we have to recognize another terminological problem. We say the average sea level or the sea level which is always going up and down. Every day it is going up and down. We have the high tide, we have the low tide. But this high and low is going up. So when we say 10 centimeter sea level rise, we always have to say it's an average and it is not an absolute value. It's a reference value. So one may not see it, but if you keep the records, one would see. Things are changing very much. As a marine biologist, I have looked at the sea rise and the things like that, and we see that in the last many years in Sri Lanka, the records are indicating that we are having what are called the tidal surges, which is something that happens in the sea. It doesn't have a timetable or it doesn't have a period or any predictive times. But there was one, I think, just last week or the week before, the people were saying the sea went back and they were wondering whether we are getting another tsunami. But in fact, that was another tidal surge. Where just before the water rises much higher than normal, you have always the water receding back a little bit and coming up. And we have been having this inconsistent, no pattern. But why it is happening, there is no idea. But they try to link it up with the famous El Nino and La Nina concepts, that is the warming and the coldness of the ocean. You know what El Nino is, right? It happens just before Christmas. So we have that word El Nino and La Nina, the female, the polar sides. We are having it everywhere now. These things have become very common. Again, the data is very clear. The sea level is rising. It is increasing. Right? We may not feel it because it depends on where you are. Then the other factor that is also important, which was mentioned by them, that is the rainfall. The technical term, of course, is precipitation. It's not rainfall. We don't call it rain. We call it precipitation. Water precipitating down. Again, you will see that there is differences. In some areas, you can see the green is the high areas, and the orange is the low area. So in some areas, there's going to be heavy rains. In the other areas, there's going to be low rain. Now, this is a very interesting area. If you have followed the rainfall patterns of India, in the last couple of 10-15 years, that corner has always had too much rain. Even now, I think just 2 weeks ago, there was a huge rainfall and there was a lot of problems in that corner. So these have been all predicted using models. Now, this is where the other issue is. The model is a computer software where somebody sits and develops, putting all the factors that might affect the patterns, and trying to say, well, this is what may happen. Now, what is interesting is, now this is somebody's pattern output, and he has said that this is what may happen. And now it is happening. Now, when you think of climate change, in 1896, a physicist called Arrhenius had already predicted all of these things that is happening today. But now, that was just a scientific statement. He said that if you increase the carbon dioxide concentration of the atmosphere, you are going to have extremes in weather, high temperatures and heavy rain. But nobody bothered about it because that's a thing that nobody was going to expect, because that's a scientific statement, right? It's not a de facto thing happening, not something that is ongoing. Nobody was thinking about carbon dioxide increase and anything like that. But he just said that. And today we know that what he said was perfect. It is happening. Carbon dioxide concentration has gone up, and thereby the temperatures have changed. Heavy rains when it rains, or we don't have rains when we want it. It is going off in different ways. So all these computer predictions are doing it. You will be surprised for what you will see for Sri Lanka, right? I'll keep that to the end, right? Looking around the hall, I don't think any of us will be around to enjoy that prediction or to see the horror of the prediction. I won't be there. But we have to accept the fact that it's our responsibility to take the message down the line. Anyway, so this is another, so increments, increasing latitude, rains, we have seen it happen. I will give you some classic things for Sri Lanka. Then going on to the biological diversity, we have had a lot of impacts. Animals have increased, decreased, their ranges have changed. All of this information is now well available. Right? We have had die-off, Coral bleach, we just had one couple of months ago in the Barif area, that is close to Putlam in that region, right? And in '94 we had a bleach in this country. The corals have still not recovered, and so on. So we have had this problem. We have had an extinction which has been recorded. The golden toad accounted for climate change or high temperatures. Life cycles have changed. Physiology, animal ranges have changed. We have situations like that. Their range has either increased or decreased because the weather pattern that results as a consequence of the climate change makes things better or bad for them, right? So many other changes are there. This literature is all available today. If you are interested, you only need to go into the internet and ask for climate change impacts, and all these things are given. I won't keep. But what is interesting is, what is the reason for these changes? Because that is where, if we are to respond to it and do something, we can do something and to understand that. After many years, they started monitoring the components of the atmosphere, and they realized that many of the components in the atmosphere is also going up. You can see here, carbon dioxide is increasing, nitrous oxide is increasing, methane is increasing, sulfur is going up. So all these gases that are part of the atmosphere are changing. So this is what Arrhenius said. Carbon dioxide increases, we are going to have a problem. Because you have a composition of the air, and you just only got to change the composition and see what would happen, nitrogen. At one time in the earlier days, when this was becoming a problem, and we were looking and telling to the developed countries, you are the culprits, you are doing this, they suddenly turned around and said, hold it, we are not the culprits, you are the culprits, in Asia especially. Why? Because if you look at it, you can see of the many gases that are going up, carbon dioxide and methane. And where is the methane generated? And Chintan was just saying about the Japanese report of the dump, right? 16% methane generated, that we knew for the last 20-30 years while it was being dumped every time. We have been always saying this is an issue you have to think about it, right? Waste generates methane. Biofuel, that's what we were talking about. There are practical demonstrated examples of how you can convert waste to energy by the NERD people, by others from Peradeniya, Basnayaka, you name it, Ajit Alvi. So many people have been saying this, but we have never bothered to listen to any of those things. But we just kept on dumping, and then it goes off. After a little rain, it makes it more active. Not just only methane, there are phosphogens that comes out in some places. People have seen this, Devatavu, gods on the dumps, the blue light and all that, and purple lights and all that. These are the gases that burn in the night suddenly. All these things happen. But anyway, methane was accounted and was said, methane generation happens in two places. One from cattle, other from the paddy fields, marshes, cattle. Right? Because cattle, when they feed on grass for it to digest, they need to sort of beautify it with bacteria, and during that process, a lot of gas comes out, methane. So where do you get the cattle? There are more cattle in India than the population, right? Because they venerate the cattle, so they don't kill it, they keep it and things like that. Where do you get most of the marshes? In whole of Asia, right? We are the rice makers and we eat the rice. So at once the equation was shifted from the developed countries, Europe and America and the rest, to Asia and India. Of course, immediately we had some good scientists, I would say India did most of the work. They went round and started saying, no, look here, we can't be the culprits. There must be something different in that, and they did the experiments and they showed. Yeah, we are the ones who produce a lot of methane, but methane doesn't stay in the atmosphere. This is called the staying time. How much years do a molecule of methane stay in the atmosphere? So general equation we say 1 to 10. So when a methane molecule comes out, it stays 1 to 4, sorry. Methane comes out and it goes off. But carbon dioxide comes in and stays on for another 3 years before it starts dropping off. So the real factor for climate change is not just simply increasing carbon dioxide, but the cumulative effect of the increasing carbon dioxide. So these are the clarities that you need to understand. When we say carbon dioxide is the culprit, we are saying carbon dioxide is the culprit because it accumulates in the atmosphere over time. Methane is a contributor. It doesn't accumulate, but it is still a contributor. So when you take it over many years, you can see that methane becomes almost negligible because the carbon dioxide amount that is accumulating, and when the increment is there, it becomes worse. So at once that was diffused, so we are happy, so we was good, and we looked at, and there was a lot of other arguments that were brought in to change the picture. The simplest reason for this is the carbon cycle. You see, very simple cycle. Carbon dioxide in the atmosphere is fixed by the plants, the green plants. We call it photosynthesis or fixing. Sequestration, these are technical words, but it is taken out of the atmosphere by the green plants, converted into starch or to material like timber and things like that, which ends up there, and thereby it reduces the carbon dioxide. But those same plants and animals, when they respire, they send the carbon dioxide out. And so that is the simple cycle that sustained the carbon dioxide in the atmosphere. Now what have we been doing in the last so many years? In the last 30-40 years, what have we been doing? This is where the change comes first. See, this piece here didn't exist till the industrial change came in, which is the burning of fossil fuel, burning of gases, fossil fuel. We didn't have that till the industrial revolution started happening. And where did the fossil fuel come from? It came from under, which was fossilized or which was sequestered 160 million years ago, when the current composition of the air came into being. We therefore take it out from underneath there and burn it to get the energy and release the carbon dioxide into the atmosphere. Now this is an excess in the equation. Greenery away. In taking the greenery away, we are effectively reducing the capacity of the surface of the earth to take away the carbon dioxide. So the net result is the increment in carbon dioxide. And this has been accumulating because the more and more energy that we have generated by using fossil fuels means that more and more carbon dioxide is released to the atmosphere, which was fossilized 160 years ago, which was not part of the equation today. So we should ask the question, who is responsible? You and I. There's no point putting it into anybody else's basket. Just saying it is the developed country alone is also not enough. Right? Because we also wanted to develop. We also wanted to have the benefits that the developed country has had, and we are still trying to do that. So we are responsible for what has happened here. The ocean was one of another cycle which was actually taking away a lot of the carbon dioxide by formation of bicarbonate mixing with the water. But once again, we have been the culprits to poison the ocean to that extent that its capacity is today considered 10% less than what it normally is. All because of human activity. We have polluted the ocean much more than what we have done on land. We don't see it. Only last year I think there was a record of in the Sargasso Sea, which is in the middle of the Atlantic Ocean, where there is a plastic mountain which is bigger than the icebergs of the Titanic times. Huge. And it's geohydral, you know him, huh? Ra, who went to go on the balsa wood boats and things like across the ocean. In Ra2, when he went on Ra2, geohydral, he said, I would not even brush my teeth and wash with the water of the ocean when I see the amount of garbage that is around. We have been doing this over the years. So that cycle also has become dysfunction. So carbon dioxide now keeps accumulating. So it has to have an effect somewhere. So the common word that we have used here is greenhouse effect. Again, you have to understand that there's a difference. It's just a word that has been used to try and explain the warming process. Sorry, not the process, the result. Because the greenhouse that we are familiar when we do plants, we increase the temperature not by using carbon dioxide, but by trapping the heat by using an insulator glass. Manipulating with water so that we can keep the right temperature. What is happening here is that the sun rays which comes down to the surface has a very small band. More than 30 to 40% of that heat is reflected off back again, and when it is reflected back, it goes as a large band. The large band is absorbed by the carbon dioxide and not the narrow band. So when it goes back, there's plenty of carbon dioxide which gets warmed up as a result of the bandwidth change of the radiation heat that comes down from the sun. So therefore it doesn't go out. All this time before the carbon dioxide concentration increased, there was a certain amount that was absorbed by carbon dioxide. If not, we would not be in this atmosphere anyway. We would not be able to survive. But now we have excess of the carbon dioxide, and as a result, excess of heat getting trapped inside. So the word greenhouse effect was used. So the contributors to greenhouse effect are called greenhouse gases. So that's why I said methane is also one of them, because they also absorb the heat. The nitrous oxides is a greenhouse gas. The sulfur dioxides are greenhouse gases, in addition to contributing to acid rain and so on, other problems. So land use changes has all contributed to these so-called emission issues. So emission, annual emission to the atmosphere has been calculated, and you can see the land use change is that when you cut the forest, you change the landscape, you expose the soils, and the soils themselves enable much of the beautification to increase, and as a result you have more carbon dioxide going into the atmosphere. So what would be the effects of this climate change? Very simple. Relative sea level rise, we have already mentioned. So because when it heats up, all the ice caps starts melting, and when they melt, it starts increasing the water level. But very recently, and maybe another 20 years ago, there was the theory that came up, fine, that is good. The original picture you may have seen, that the northern hemisphere gets warm, but the southern hemisphere gets cold. So we are seeing a freezing situation in the south, while we see a incremental temperature in the north. So now people are arguing, don't worry, this is not a problem. Even if the temperature goes up there, it is getting cooler down there, so then it will stabilize someplace. But again, when you look at as an oceanographer, or looking at it in a marine sense, it is this temperature that makes the circulations of the ocean waters which affects the climate, and especially a country like Sri Lanka, which we say we are an ocean island, because our climate, our weather especially, is all a result of changes in the sea, not anything to do with the land, because we are too small for that. We don't have convectional rains. All the rains we have are very much the result of what happens in either Bay of Bengal or the Indian Ocean. Right? So anything happens, the monsoons, if the monsoons get late, all of we are getting affected. But then what happens in the ocean is a result of the changing temperatures of the waters. So if the northern pole is getting warmer and the southern is getting cool, doesn't mean that the atmosphere is going to balance off. It's going to make things even worse, because all the so-called trade winds and so many other things will start changing, which means that that's why in some parts of Africa it is getting warm, the other parts it is getting cold, and so on and so forth. So these consequences are huge. They can affect a lot of activity. If you look at the global situation and look at Sri Lanka also, much of the human populations are on the coastal areas along water edges. So the water levels are going to contribute to changes. The fisheries people are going to be affected. The tourist industry is going to be affected. Some countries are going to go underwater. We know Mali had a parliament also underwater, just to show that, they are concerned about the global warming and the whole country going underwater. The calculations are that only something like 25 square meters of Malay will remain once the actual so-called predictable levels of the 4-meter sea level rise, if it ever happens. Right? Quarter of Bangladesh is going to go underwater. The entire Sundarbans area, all of that is going to go underwater. We did a prediction. Prof Sarath Kotagama, along with the coastal conservation people, did a very simple thing. If it is 90 centimeters or 1 meter, we are going to have the entire coastline right round. You can put the contour line of the 1 foot and the 10 meter of contour, and you will see a lot of areas going underwater. So this still remains a threat. We will not see it, but it can happen. One of the reasons why I talked about tidal surges is that the tidal surge is very much a consequence of the ocean current changes. So we are going to be affected, and a very practical one is that we have seen north of Putlam, Kalpitiya, there is Batalam Gundua. For the last 15 years, the sand dune, which was a continuum from Batalam Gundua to the top, broke off in 2002, and it's still broken. It has never formed again. So we have added an island to Sri Lanka, a sand island, because that connection, which did not exist before 2002, when it used to annually break and connect, did not close after 2002. So all the currents have changed. Right? So this is happening all the time. Right? So we have to be concerned about it, but we don't see it, we don't physically see it, we don't visually see it. So we have very little data collected for it, and so therefore we don't know what is happening. There's a lot of concern about effect tourism and all of these things, and there is that one given invasive species increasing risk. This invasive species coming from the ocean. Again, one might think, oh, this is what is it? But if you look at what is happening in New York, the Boston area, the Lake Erie, those 5 big lakes, they have a huge problem because the zebra mussel, which didn't exist in that corner, came across from the Atlantic into the warm areas and now have established. It's a razor type of a mussel, so it's having a huge impact on the ship movement and the problems. Then there is the petromycin, which is a fish that gets stuck onto fish. They are moving inland and they are having a lot of problems as a result. Right? So when you have a fishery that is dependent on things like that in low temperatures, it is there. The polar bear is having a problem because it doesn't have ice to move around. It's breaking up and more islands are being created and they are getting isolated, and as a net result, there's a lot of consequences there. High temperature, obviously, I don't have to say much about it, but we know that this is going to be a major factor. Already we are experiencing it. The rain patterns will change, the cyclone patterns will change because of all the weather patterns. It's a consequence of temperature change. Right? When it heats up, the differential, we call it the differential heating, because the globe is round, so the poles are cooler than the tropics, and if you are going to get more heat and more heat is going to get trapped, then the storm patterns, the cyclones, typhoon, all of these are showing very clearly that the number of cyclones are more than what it was, the intensity, the frequency, all are changing. The intensity is higher, the frequency is more, so they are waiting for the records to break this year when it starts happening, and all are now very clear. It's much a factor of whether you want to believe it or not. So, as I said, the oceans regulate the Earth's climate through carbon dioxide and heat, and when that changes, everything is going to change. Precipitation is going to change, definitely. I'll give you one simple example which all of you have had the experience of being with. 5th of June 1992, Colombo went underwater. 5th of June 1992. And the rainfall was 592 or 98 or whatever it is. It was in 590s. The parliament went underwater for the first time. The damage was not very much. We had the water for about 2 or 3 days. The biggest damage was down Flower Road, that TG Jayavardhana Mamatha, where they had water for about 5 days. And when they pulled out the polythene bag from the block, the water came down in no time. right? So it was a few polythene bags that kept the water for 5 days when they realized it. So this is how we realized it. And then we spent 1,086 million loan money from the World Bank, which we call the Greater Colombo Environmental Improvement Program. For the first time, we see gabions in Sri Lanka. That is the rock enclosements in aluminium boxes on the sides of canals. It's the first time for Sri Lanka. We dug the entire canal system to be below 1 meter mean sea level. The whole idea was detention of water, keeping the water and detaining the water when it rains. For a very simple reason, because at that time also we understood that the more we build, the more we reduce the percolation areas of the ground, the more it will flow sideways and fill the lower areas, and you will have a very quick increment of water. For some of you all who may have been around Devi Balika, Kanatta Junction, one rain, 30 minutes, it's underwater. Today, of course, you know, Kanatta was raised by 3 meters, Devi Balika was raised by 1.5 meters, filled, and we got over that problem. Right? But then we had a rainfall in 2012, when the parliament went underwater the second time. Now, having spent 1,086 million, a new barrage at Telangana diverted the water from Homagama, because we never want the parliament to go underwater, to Kalania, having done all of that and created a huge drainage pattern system for Colombo, we go underwater in 2012. And the rainfall, less than 450 millimeters. So less than 150 millimeters of what happened in 1992, we go underwater again. And this time a calculation was done. Because not only did the parliament undergo water, it actually filled the entire basement. 92 it didn't be so much damage. But this time, total damage. Basement was gone. Right? And all the roads that we were reconstructing after 2009, from Anuradhapura to Jaffna, just got washed out. Nobody talked about that because the parliament was too important. The Apples were taking our members of parliament to the chambers and things like that. So nobody talked about the rest of the damage that happened across the country everywhere. A calculation was done. Anybody knows how much it is? 30 billion rupees. This is the bank value. 30 billion. Right? So when people talk politics about taking loans, I said, who gave 30 billion? To bring us back to where we are. Somebody had to pay this. That's the question. The rains. The rains damaged 30 billion for us. Right? But we still recovered it. We brought loans, we brought this, that and the other. The roads were reconstructed. The parliament basement was done again. Additional wall space was raised. Did everything. For 150 millimeter less rain, for a lesser days, we had this problem. Now we are going to face the next, if at all. We have to be ready, right? Because this is the precipitation that we have to expect all the time. And it's going to be worse. Flooding increases. Because the rainfall is coming down in a large quantity in a short time. And it is not going down to the earth because there is no surface for percolation. Every space has been covered by a roof or an asphalt or a pavement. So we thought that when the interlocks came into the picture that we were at least having some sense of increasing the percolations on the pavement without putting the asphalt. But then we realized that it is only on the surface that you find the interlock, because underneath that you anyway make it almost impervious. So we are losing the battle again. Right? So the more you construct, the more you put buildings, the more you cover the surface of the ground with percolation, non-permeating substances, the more you make the flow faster, and when it comes down in such large quantities, the immediate impact is fill, because it can't go out. There's very few water outlets in Colombo, only two. Devala, Lavanda, and the other one is Verasganga down at Polgoda, where the water level has to be pretty high to go backward all the way down. Right? So we are still going to face this problem every time it rains. The coastal erosion has increased and it continues to increase. So I won't to take much more time of what is going to be there. All this I have mentioned, right? Then what is the future? It's going to get worse. There is no question about it. Despite the fact that today we are very unhappy as environmentalists that the US government has decided to think that climate change is not an important factor. When we really have to think of it as an important factor, when we have decided last year, 2015, so year before last, 2015, we said 1.5. We won't allow the temperature to increase beyond 1.5 degrees centigrade. At least 2, we say 2. If we can contain it to 2, it will be an achievement. If we don't do it, we are definitely going to have a problem. There is no questions about it. We are going to face a lot of problems. So these all are going to be much a factor. So the data is very clear. I won't take time here. You can see where it can affect. The health is going to be impacted because a lot of diseases, dengue, you name it. Right? There have been 32 emerging infectious diseases since 1982. And the frequency of EDIs, we call emerging infectious diseases, have increased over the last couple of years. Every time you turn around, you have something happening. And I was even more surprised when in the last couple of weeks, everybody said there is H1N1 and it is affecting people in this country. To find that it is not the H1N1 of the bird flu, it is a variation of the bird flu that is affecting the people today. Because if you get H1N1 that affected the Southeast Asia, you would die, there is no question. Right? It will be only 1 in a million if you survive. But here it's a variation of that. See, all these are happening with the temperatures. When you change the ambience, mutations are quick, fast, viruses all over, we still don't have a cure. We can only prevent ourselves from getting anything worse. Allow the system to look after. Agriculture is going to be affected, the forest is going to be impacted, water resources, you name it, everything we have. So whole heap of this information, I don't have time. Right, numbers are going down, very well predicted. The global biodiversity is decreasing as a result of climate change. The whole polar systems are going to move apart. Distribution changes, agriculture effects, water. Sri Lanka is still not, you will be happy, is not still in the red spot for water. Despite the fact that we are having droughts and things like that, Sri Lanka in the global picture is still a country which will have water. Right? But that doesn't mean that you can be happy about it, because where the water is going to be available, definitely is going to be different. So I want to quickly, oh sorry, I have not put that picture. Anyway, what is going to happen to Sri Lanka? See, 1994, Dr. Dhanapala and Somaratna were correct, but what is sad is that the intensity is going to be higher, and we are going to have it not in 100 years, we will get it in 50 years. So now where do we stand then? Right? Which means that within some of the life periods of those who are living today, by 2050, 2075, we are going to start seeing the reversal. This was also supplemented by the team from geography at Colombo, Mr. Wilson's team. They looked at the dry zone, wet zone isobar that changes the dry zone and the wet zone. And they realized it that when they did the analysis, as I said, we have good data, they realized it that it has already shifted 5 kilometers inside. So the dry zone, wet zone line that we were familiar when we were in school and when we drew, if you draw it today, you have to remember to draw it 5 kilometers inside. The textbooks have not changed it, so we are still teaching the same old wrong information today. Right? It was right then, but it is not right today, right? Because the textbooks have not got these things into their head yet. So many things like that are happening. The tea industry is going to be directly affected. So how do you look after that? The vegetable production is going to change. It is true that Jaffna has cabbages, it has beetroots, it has carrots. Right? So maybe we'll have to forget about the hill country beetroot and the carrot and the leeks and think of only the dry varieties. We may have to think for options like that. But yes, the agriculture people are doing something. I wouldn't say no. Right? We are concerned about what is happening because the change that Sri Lanka is going to experience with climate change at the lowest temperature change is going to be drastic. Right? What can we do? Now, that is the biggest problem. You can say, no, what can we do? Right? How much of us are the contributors to this global scenario? As I said, we are all contributors because we are the ones who are gushing the carbon dioxide into the atmosphere. And as long as we are using fossil fuel, we will be contributing. So that is why in 2015 the decision was taken, zero carbon development by 2050. What it means is that by 2050 our development is not going to use fossil fuel. We will have to do otherwise. So when this decision was taken, I asked my good friend Dr. Katakoda, who was the Secretary of the Energy and Power, you are going to commission Sampur in 2022. That was going to be our next largest coal power plant generation. But you will have to start decommissioning it from 2030. Because from 2030, the world market is going to be closed for fossil fuels gradually so that it becomes zero by 2050. So why should you therefore commission Sampur? You know the result today? Today you know, no, there's no Sampur. Right? Nothing to do with climate change. But see?
Already decommissioned.
Already decommissioned. But what is our plan to change our energy? We were a country where 65% of our energy was from hydro. Today we are a country where 85% of our energy is from fossil fuels. So we are a good contributor to carbon dioxide and a good contributor therefore for climate change. So we have a huge responsibility than those who were there before us. We have changed the system. So what can we do? I often say, personally you can do a lot. At least to be happy that you are not going to be part of the story of continuousness. One, you must be conscious of the fact that you have contributed. Because what was even worse is that in 2000 there was a commission, the Millennium Ecosystems Study, commissioned by the then Kofi Annan, who was the Secretary General of the UN. And when that was what we call the health check of the planet. The health check of the planet. They looked at 38 indicators. More than 900 scientists got involved in this. And when the results came out in 2003, not a single indicator was positive. Very simply, the planet was sick. It is sick. And what was even more interesting is that it showed us when we started becoming sick. Not just that we are sick. It told us that we started becoming sick only after 1948. And that we know why. Today we know why. Right? The current development phase, the current trends of our lifestyles, they all started soon after the Second World War. So we, all of us here, right, because we have all been around all this time, right, are direct contributors to the current situation. So we cannot say, well, I didn't do anything. But I always say, I am excusing myself from you. Because from 1968, I have been shouting that this is not the way to go. That this is the wrong path. There is a problem in this path, and therefore we need to rethink. And today everybody is rethinking. But then we have come to a situation that it is extremely difficult for us to now reverse ourselves to a different strategy. So I'll give you a last example and stop my telling all this. See, in 1994, we were one of the few people who tried to bring into this country the hybrid. Because we didn't know all this at that time. We thought that was fancy, that's very good, it's going to reduce the fossil fuel consumption and all of that. But we did it then very much more than the fossil fuel consumption, because we were using leaded petrol in 1994. We thought this is the best way to get rid of the leaded petrol. Bring in electrical and stop the leaded petrol. Anyway, now we are all going for hybrid. But do you know that in a country like Sri Lanka, the hybrid will become environmentally friendly only after 35 years of its function. And you won't have that vehicle by that time. Because these vehicles are not meant to function for more than 5 years. Right? So every time you go for hybrid, please remember, you are not environmentally friendly. You are only thinking you are environmentally friendly. Because to produce that car with a conventional car makes no difference. In fact, it is much, much more environmental harm. The battery requires lithium. Lithium production is one of the most polluting industries in the world. It happens in 3 parts of the world, and in all 3 parts it's total disaster. Okay, you have a fantastic battery, you have a fantastic running vehicle which doesn't gush out any carbon dioxide, so you are very happy. But I ask you this question: what is your plan when you have bought that vehicle to discard the battery? The country doesn't have a plan. What do you do with that battery? How do you discard that battery? And whenever you charge that battery, you have to charge. If you have a total electric vehicle, please remember, hybrid is one, but go to a total electric vehicle thinking I am even much more happier doing good for the environment. How are you charging that battery? By contributing to the atmosphere carbon dioxide. So you see, this is all good until you convert your energy production away from carbon dioxide emissions. That's why we are saying solar, solar, solar. That's also nice, very good story. But solar is also the same. Has no difference. It's still going through the same problem. But we are going to be happy. You are nicely seated, no? Hot outside. Why? Because of those 2 gadgets. They have converters. They all have a green label, but they are still the same. They are still causing the same problem. So we are happy by doing good with what is bad. Right? We are very happy by doing good with what is bad. Technology is making us a little more happier, saying that, fine, you are green. So you see, it's a very big problem. How do you contribute to make a difference? It's going to be extremely difficult, but we have to. If we don't make those right choices today, we will not be making the right choices for tomorrow at all. We will just only contribute this doing good from what is bad. So my philosophy is, you must do good with what is best. And what is best? Nature. There's no substitute for that. Nature is the best. So if you want to do anything, do it with nature. And we have a subject for that also. We used to call it inspirations from nature. Today there is a subject called biomimicry. Mimic what is in nature and you probably will end up doing better. So you have the first green band at Nitambo, where they use the trees instead of the air conditioning. So I will stop at that and leave